We'll have
And
fun.
so I'll talk to you guys later about it.
Okay, we're going to talk to everybody right now. Hello there. Happy Star Wars Day, everybody. May the 4th be with you. This is, ladies and gentlemen, the 271st edition of our weekly vlog, the SBAU Astro Hour, all for education, for fun, and coming to you from the Santa Barbara Astronomical Unit, longtime astrophysics and telescope club for Santa Barbara, and from Santa Barbara, California. It's all based at our town's beautiful Museum of Natural History. I am your proud host. My name's Ronnie Heron. I'll introduce you to the very distinguished and knowledgeable gentleman sharing the Zoom screen with me from SBAU. Learn all about us at sbau.org. And you are invited to our first Friday of the month general meeting, except you just missed it. It was Friday night. It'll be 2 months before we get another one. You've got a month to join the club. Come to our potluck next month, June, and bring your favorite casserole. And doggone, we turn it into a Golden Corral all-you-can-eat buffet right there at Fleischman. Second Saturday of the month coming up, though. That'll be our star party this weekend, all held at the museum. We've got 5 years supply of weekly Astro Hours saved on YouTube, and you are welcome to leave comments and questions down below in regards to these cosmic topics this week. It is the full flower moon at the start of the merry month of May. In fact, there's two of them. That makes them blue moons. A lot of moon stuff. It's in a gibbous phase, might interfere with the raining Eta Aquariid meteors, which are peaking on Wednesday. And get this, folks. Debris from a SpaceX Falcon 9 rocket launched last year could very well crash on the moon, create a new crater right in front of us. China's Chang'e 5T1 mission already did. Well, let's see. We're going to check out the location of our 8 sibling planets, our various positions around Papa's sun, both evening and morning. And in honor of May the 4th, right up to sunset, we're going to catch Thor's helmet, assuming Thor is willing to throw it, or the Duck Nebula. You're going to see what Europe's big telescope in South America saw in the Triangulum Galaxy, and a space photo of the Sombrero Galaxy, plus something about Abigail Freeman's favorite topic, the Curiosity rover, which we had talked about on Friday. Let's meet the gang. Ladies and gentlemen, this is our captain of the club, man with the PhD that we don't call a doctor, President Jerry Wilson. There.
Good morning, everybody. Good morning, Joyce, and good morning, Calvin and Riley.
And wouldn't you know, what a coincidence. He happens to be married to our club's first lady, Pat Forgy. How'd that happen? Jerry Wilson, thank you. Our incredible outreach coordinator for SBAU is the only man still with a pet rock that he feeds daily. He pet it on Friday night, Chuck McPartland. How is Pat doing? She missed the meeting Friday night.
Yeah, she's doing fine. She has another post-op check today, so things are going good.
Yeah, it's those damn loaners they get you when your eyes have to go into the shop and you got to use the damn loaners.
Yeah.
Bless her heart. She's also our treasurer and merchandise manager. Let's see. Here's Tim Crawford, who is a longtime SBAU supporter, Star Party participant. Tim, good to talk to you. Good to see you.
All the time, Ronnie. You got it.
I don't know how you go to Ireland every week to be with that picture behind you every.
I'll put a picture of Guinness up there next time.
Okay. He's married to a lovely lady named Karen. Tom Whittemore is our newsletter editor, former Westmont College science professor, dedicated birder and bread maker. And how's life with you, Tom?
Oh, good.
You and Maureen dining out a lot, or do you eat at home mostly?
Mostly at home. Yeah.
I smell sourdough bread a lot at your house.
You got a good nose because it's baking right now.
I smell it. You got it. Okay, we do these silly cartoons that are forwarded to us, usually science-based from Jerry. Like the goldfish in the bowl, and what have we got? The observatory, the guys on the edge. There were 6 of them sent to us, I believe. Or was it 7?
Yeah, that's one added later.
Okay, you're going to have to expand it. Here we go. What are they talking about? Anybody want to read that? Tim, why don't you start us off? Read what's going on here.
These 2 guys are standing outside their observatory and looking up at the sky. They're truly amazing, truly amazing. And the other guy says, but then again, or maybe it's just the same guy saying it. But
Yeah.
then again, you can't discount the seen one, seen them all theory either. Kind of like that.
A lot of them are binaries, but they look single to me. I'm sorry. That's a good one. All right. Jerry, what's this one all about? How come?
This is a lady interviewing to go to Mars with NASA. And this is the Mars expedition job interviews, and she's being interviewed, and her background is I'm allergic to blue planets.
Blue planets.
And you see she's got a dripping nose, so she's really got to get there.
I believe Abigail Freeman said there is some blue up there, according to Curiosity, but not a lot. Rusty red. Okay, Chuck, why don't you get us through Bruno the Philosopher Fish? What's this all about?
Okay, Fish sitting there philosophizing, and he says, "There is the bowl. Beyond the bowl, there is the room. And the room must be infinite, for what could possibly be beyond the room?"
Well, the only thing I disagree is it should be finite, not infinite. Nevertheless, we get the point. Here we go. Tom Whittemore, what are we doing here? Where are we, in the classroom?
Yeah, looks like a teacher. Lady, any questions? The kid says, if we build a base on the moon, will they celebrate Earth Day?
That's a
Only if
Fraz
it's not
cartoon.
cloudy. Does anybody know what cartoon that? Oh, here we go.
It's
What?
Fraz.
Oh, is
Yeah.
it? Okay. Jerry, you want to read this and explain it?
Scientists have finished a study on how alcohol can affect a person's ability to walk. The results are staggering.
That's pretty good.
We're not above a cheap pun here.
Yeah,
Should have given that one to Tom Whittemore.
Yeah,
Well, Tom, you want to try this one?
sure.
Must
This
be
is
new.
30-minute parking only. The SS Hibernia. What's Hibernia, Ron?
Is that a star somewhere?
No, it's
No.
what the Romans called Ireland. So it says
Okay.
30 minutes. How are we supposed to collect enough rock samples in 30 minutes?
They've got a ticket under their windshield wiper, and here comes the tow truck.
Oh God.
In orbit.
Yeah.
You know, I don't recall getting this one. Is this
No,
Well,
you
this is a
didn't.
new
I
one.
found this after I set out the funnies.
the SS Hibernia? That's
Yeah,
here we
this
go.
is cool. I like it.
Jerry, you're probably going to have to guide us through this.
No doubt about it, Ellington. We've mathematically expressed the purpose of the universe. Gad, how I love the thrill of scientific discovery. So this is reminiscent of the first time that I was studying general relativity, because it was written as an expression and it equaled zero. And I thought, this is the secret of the universe. It's nothing split into co-equal but opposite halves. But if they ever get back together, it goes back to nothing.
Whoa, deep. That's similar to something I proposed that you said I was crazy about. I called it duality. Everything's duality. Opposites, up, down.
That's one approach.
Positive, negative. But, you know, we got a whole hour full of stuff to talk about here, mostly the moon and the planets. And there she is.
So anyway, this is our moon, a full moon. And the full moon was actually Thursday evening or Friday morning. And so it's a little past that now, but still, for where I am, the full moon's a little irritating because it sheds too much light around. But it's a good place, as Astronomy Magazine points out, it's a good place to look for the ray systems in the moon. And this is from a British site, I think. And it's coded in the caption of the frame in our talking points. Number 1 is the ray system around Tycho. Number 2 is Copernicus. 3 is Kepler, right there. 4 is Aristarchus, right up there, smaller, but still there. 5 is Proclus, right over there.
That one I don't know.
part of the ray pattern's missing. So I guess there must have been a mountain peak or something that.
Yeah, you can see the rays right over the Mare Crisium.
Yeah.
A
Yeah.
good night.
And then 6 is Bergius A there. And 7 is Messier A, which
Messier.
is right here. And I don't really see a ray system around it, but I'm assuming there's one there.
That's one where it's an oblique hit and a shallow angle, and so you see a splash coming out of it.
Yeah, that must be the splash on the edge there.
Messier got a crater named after it.
Yeah.
Who would have thought?
Yeah.
Driving home Friday night from the meeting, boy, I had a great view looking right at it coming up. But a blue moon is actually 2 blue moons, isn't it?
Well, that's a new definition that was a mistake that's sort of been adopted. Nowadays, like they're saying for May, it's a blue moon month because you have May 1st and May
31st.
31st.
and then yeah, on the 31st you have another full moon. So it was a mistake made by somebody that in 1947 misinterpreted a farmer's almanac talk about a blue moon. What a blue moon used to be defined as is much rarer. It's the third full moon in a season that has 4 full moons.
Oh,
What?
Yeah.
That
Well,
has
much harder to figure out.
four.
Well,
There's four full moons in a month.
No,
No,
in a season.
no, a season.
Season.
in a year.
Oh,
No, in
okay.
a season.
I would
Spring,
think there'd be
summer, winter, season.
seems like there'd be a lot of them since the moon's orbit is 28 days and a typical month is either 30 or 31. You'd think there'd be a lot of 2 full moons in a month. Wouldn't
Nope.
you?
I've never heard that.
Yeah.
I've heard the new one, the new definition, but the
Right.
old that's really neat. I've never heard that.
Well, the new definition sort of took over because it's much much easier, but it's also much more common than the
Yeah.
old blue moon definition.
Right. And the
But what-
phase cycle, Ron, is 29.3 days.
Oh, it is.
Yeah.
Why blue? Why blue?
They just picked a color.
Oh, okay.
Maybe someone was sad on that day.
So the old thing is four full moons in 3 months.
No, it's
Oh.
it's the third full moon in a season that has 4 full moons.
Okay.
Okay. Not right on the top of it, not really obvious, but I guess there's a rationale somewhere in that.
What's the gibbous mean? What's gibbous moon?
Gibbous means growing, humpbacked. Comes from an old English word that means humpbacked.
Well, you lost me. I don't know
It's
what you
halfway,
said.
it's partway between a first quarter and a full, or between a full and a last quarter.
Right.
Oh, got it. Gibbous. That doesn't-
Okay, this is our evening sky, looking for 1/3 of the roundup of planets, see where they are. Uranus is down here, aka Doug. And let's see where there's
Jupiter's up off the top. Venus is
we
right
get to
there.
Jupiter separately. I thought there it is, Venus, the evening star right there. So this one covers Venus and Uranus. Venus is unmistakable in the evening these days. It's a very bright star in the west. The Jupiter is above the last picture, looking higher up. Jupiter's right here in Gemini. Used to be between the two, but now it's over on the Pollux side.
Mhm.
And this is early evening again, about 8 o'clock. And that's actually, it's not really black at 8 o'clock, I noticed last night.
Yeah.
It's a little grayish still.
The time of the season where we set up our telescopes at the star party and tear them down.
Yeah,
Yeah.
before it gets dark. And this is the morning sky with Mars just barely up. This is 5:30 a.m. And I had to tweak things a little bit to get Mars to be above these houses. Saturn is here and Neptune is up here. And Pluto has sort of fallen off our chart. We don't talk about that anymore. But I understand there is a growing movement to try and reinstate it as a planet.
Oh God, yeah.
And of course, Neil deGrasse Tyson's favorite phrase about Pluto is "get over it."
No.
So if you're up early in the morning, 5:30, it won't be this dark either.
And the Aquarius is there in the upper right, and that's the radiant point for the Etas. We'll
Yes.
get to that, I guess, but
So this is a why am I not able to think? Thor's helmet is an interesting nebula up here. It's a popular one with imagers. So this is about 8 o'clock in the evening again, with the planets somewhere in here. Or I guess we're too far south.
yeah.
Looking
to see
south.
them.
And this is, I don't know why Astronomy Magazine does this, but they wait until it's getting bad to look at an object, and then they feature it, you know?
I know you've pointed that out several times. I think this time they're doing it to get away from the rising moon. And so it's early in the evening before the moonlight really goes after it, because this is a nebula. And with the full moon or a big gibbous moon, you're not going to see a lot of nebula. But this is
I mistook Sirius there for Leo. So it's Thor's helmet's just above Sirius. Okay.
This is Sirius, yeah, right there.
I wonder if there's a good star hop to that.
There's
there is.
Sirius Thor's helmet.
Yeah, these
Two
two stars
Mirazoms,
right
Sam.
here point right at it.
It is.
Mirzam too, the front paw.
You could go Mirzam Sirius right to Thor.
Oh, okay.
Oh, yeah,
Good one.
That does too.
That's a good one, Tommy.
Yeah, those are bright.
Either one of those, yeah, those are brighter. Yeah, I like that. I like that.
Some people think it's a Viking helmet, others think it's a duck.
It has the name of the duck, but that was reading that on the internet that was the first time I'd ever heard it called the Duck Nebula.
Yeah, I've never heard that.
Yeah, Ron, if you called you must be daffy if you called it.
But that's all, folks.
Yeah.
You what?
Nothing. I'm doing the Looney Tunes.
Okay. Now this is a film. Excuse me. This is an image that was taken. The data was taken from available data on the internet and processed by an amateur, and he signed it down here. But I can't find his name other than that signature, and I can't decipher it. So whoever you are getting credit. But I don't know what it is. But anyway, it's a very interesting thing. You can go to the various websites, including Hubble and other websites. They give their data online, and you can download it and then process it. This guy, I think his calling number is Jada 91, JEADA 91. But he's processing information from the telescope live data. And this is H alpha, oxygen 3, and sulfur 2. So these are very narrow band filters that take pictures of just those specific elements. Because they're very narrow band, they don't let a lot of light through, but when the light does come through, it's those specific elements. And so it takes a long time to take pictures to let that light build up to form an image. And the total exposure time on this picture is 2 hours and 40 minutes, the sum of all those bands. And it was taken with a 1 meter diameter telescope, not his telescope, someone possibly Elcos.
Yeah. Very, very likely it was Las Cumbres.
Yeah.
Las Cumbres specializes in time domain astronomy, so they don't tend to do stuff like this.
Really?
But if the information is out there and available, for example, I know NASA, since the American public owns NASA or funded it, that data is all available. The trick is that with NASA, they don't correspond with what amateurs are usually equipped to handle, which is LRGB, that is luminance, red, blue, green. They don't take pictures with those bands in mind. They're after specific, scientifically interesting colors. So you have to figure out a way to convert them to what it would look like in a red, blue, green pattern.
God.
And so the next picture.
Well, wait a minute. Before you leave that one, can you go back? What is that big, round, bright sphere in the middle all about?
That
It looks
That's
like a
the
Dyson.
hydrogen outer shell thrown off by this star, which is a Wolf-Rayet star.
Oh, we're going to talk about that later.
You know, Jerry, I still remember being up at Lake San Antonio in the earlier years when Tom and I went up there. Steve Kennedy, who was a renowned mirror maker, he had a brand new finished 24-inch mirror, and he sent me up the ladder. And he had a go-to platform, and man, that he just hit it. And that view here is very reminiscent of what I saw in the eyepiece in his scope. I mean, it's nothing like this, but
Yeah.
he had an amazing view through that scope.
It looks like
Yeah,
it has
it's
four
like-
spikes. Looks like spikes on a star, except they're not. They're just arms of what? Gas?
This
Sticking
is
out?
just, yeah, these are just jets of gas that has collided with itself, run into itself. This is a globe that's the outer layers of the Wolf-Rayet star. You know, it shrugs off. It's unused hydrogen in the outer layer. And so if you take a spectra of a Wolf-Rayet star, it shows other elements, not hydrogen for the star's photosphere. So they're very interesting. They're large stars and they're very rare. I think there's several dozen of them known in our galaxy.
You know, one more comment, Jerry, before you leave this is that
Yeah.
Dick Beam has been doing some HR diagrams on stars.
Yes, he does.
It would be interesting to see him do one for Thor's helmet.
Well, a
Oh,
second
it's a
comment.
single star, Tim. You can't do an HR diagram. I
I
mean, you
think
can
he,
stick it
I
on
think
an
he
HR
is.
diagram.
Well,
Well, I don't know
Yeah,
what he's doing.
he does those HR diagrams for globular clusters and open clusters that he takes pictures of.
Oh, I see. Okay.
you know what the spheres in the middle look like to me or remind me of? The sci-fi conjecture of Dyson spheres around stars.
Uh-huh.
It looks almost like it's been made by an extra.
You know, a Dyson sphere is, I think I forget his name was Dyson, but I forget his first name. But he said that a civilization that can make a Dyson sphere will harvest all the energy that star is producing through fusion. But what it is either in its extreme form, it's a total sphere around a star.
Yeah.
Say at the orbit of Mercury or something, completely around it, just catching all the light. The material that it would take to build that is not available in a solar system, any solar system. They're very fanciful objects.
They're also dynamically unstable if they're a solid sphere.
That too.
Yeah.
So lately I've seen people backing off about a Dyson sphere would be a series of plates around, like the equator of the star, all linked together by ropes or something. So,
Or a Dyson swarm, which would be like a Starlink constellation.
yes, yeah.
Well,
So there's something in the realm of Ringworld by Larry Niven, the science fiction series, which is very fanciful. And even the Ringworld would be unstable. So
in other words, like this looks like it would just be frames or, an erector set framework. It's not a full sphere. But if they came up with a full sphere, it'd be awfully hot in there, wouldn't it?
that's the idea, to catch the heat.
Whoa.
And then what they're going to do with it, send it somewhere, beam it out, I don't know. It's a
We wouldn't be able to see the star anymore, would we?
no, you wouldn't. It would just disappear. Oh, like that one in Andromeda did. No, the one in Andromeda collapsed into a black hole. It just winked out.
Wow.
Anyway,
Well, this just looks like the depiction. There it is again.
yeah, this is a picture taken with a 32-inch telescope at Mount Lemmon and processed by Adam Bloch. And this is what it looks like in RGB light.
And it looks more like a duck here.
Yeah.
A duck head, anyway.
Really?
I don't get the duck out of it. I mean, the duck
he's kind of looking, his beak is pointed down toward the lower right.
This
It's
one?
his head. It's just his head, and his beak is pointed down toward the lower right, and the Wolf-Rayet star is one of his eyes, and the other eye is off on the edge. Yeah.
So, but that's completely ignored, unless he's got like some seaweed in his mouth.
Yeah, that's ignoring the streamers.
Yeah.
Yeah, but gentlemen, as Tom Whittemore would say, if it walks like a duck and quacks like a duck, doggone it's a duck, okay?
Yeah.
Tom
Okay.
That came back.
So,
A deer just walked by.
You just had to duck out.
Oh, wow.
Yeah.
You missed the
I see the
joke.
duck now, and now I can't unsee it. Thanks. So anyway, I keep getting my phone here. I keep getting notices on my security camera in the backyard because a crow keeps flying by it. And it lands on the railing next to the camera, and then it looks in the camera, and my camera says, "You've got to look at this." So anyway, it turns out that there are, as I said, Wolf-Rayet stars are very rare. So why are they rare? Well, the first thing is that when stars are made, they're defined by their mass. And there are many more. These are the relative number of stars by population, by numbers in our galaxy, and probably other galaxies too.
The
So
ratio.
go ahead, someone want to?
No, I just got to say this is the ratio. This is how they stack up sizes.
It's the population relative to the mass. The mass is below.
Yeah,
right. So
so our sun is, this is a log scale. So our sun is probably about there. And there are about this number of yellow dwarf stars like our sun. And the vast majority of stars are these smaller ones, and red dwarfs, and even down here, probably many, many more brown dwarfs. And then you get up here into larger stars. The color represents the temperature. And that is, the red is cooler, the yellow is hotter, the white is even hotter, the blue is even hotter than that. Just like a blacksmith working iron in a forge. They can see the color of the iron he's working on, indicates its temperature. He doesn't need a thermometer. So for every one star that's of this mass, probably here about 100 solar masses, you get all these other kind of stars. So this is the one that has a chance to become a Wolf-Rayet star. So there's very few of those to start with. The other thing that plays into this is that as the star is more massive, it's crushed together more, it's hotter in the center, so it burns through its fuel faster. So here in a mass where there's, say, remember the other one went up to 150, so that's way out there. For a 30 solar mass star, the amount of time it's going to be shining is about 10 billion years. 10 million years right there. A billion years is up here. Our sun has a mass of 1 solar mass, so it's way up here. It's actually off the chart. Well, no, it's not. About here, about 5 billion.
Yeah, this is a simplified curve.
Yeah, it's not, yes. So we catch, when you see a Wolf-Rayet star, it's massive, which makes it a rare bird. And the second reason is that it's passing through a stage of its life that you have to catch it quick because it's going to disappear. it's going to either become a neutron star or a black hole.
So Betelgeuse is one of those?
No.
No, it's not that big. Betelgeuse is big, but not that big.
Oh, so the supermassive, the monsters are rats, wolf
Yeah.
rats.
Just before it becomes something, explodes, it goes through this wolf rat phase.
Hmm. Yeah, because I noticed in definition, it's a star, it's a large hot star that solar winds are being thrown off really fast,
Yeah.
or a lot of
And
it.
it's throwing its hydrogen shell off. So if you see it, the disk of it, of the star, your spectroscope will show the other elements. It's poor in hydrogen on the surface.
Jerry, why would it throw off so much uh,
Well,
of
it's
that?
so energetic. There's so much energy coming out in the form of photons and probably just even motion that
What
it.
co what causes that is what I'm saying. What would is it just before it explodes?
It's the heat in the interior.
Okay,
It's fusing stuff ferociously in there.
Yeah. Yeah.
okay. Yeah,
So
I was wondering why that happens, but
Well,
yeah,
we have a solar wind off the sun. It's the same thing. It's just a much weaker version.
yeah, yeah.
but you see those videos on YouTube of the comparisons of a dinky little marble next to a beach ball, which would probably enclose our whole solar system, wouldn't it? They're that big.
Well,
I've seen them enclose out to Mars or Jupiter.
yeah.
Okay,
Some of
well,
the really big ones might go out as far as Saturn, but
Yeah.
and that's a very tenuous outer atmosphere. So that's almost like the bubble on those Wolf Rayets.
What is it?
okay.
Herschel's Garnet Star? It's one of them.
Yeah, yeah, that's one of the biggies. But that
Okay, moving
atmosphere is
on.
still bound.
This is the central radiant at 5 in the morning. We're down to Saturn is still there, Neptune in the morning, 5 o'clock. But this is as high as the radiant for the Eta Aquarians gets at that time of the morning. And so this will be today's the 4th. It'll be tomorrow night to Wednesday morning, I think. So yeah, this is Wednesday morning, May 6th. So you look around here and up above, and that's where you will see the streaks of the Eta Aquarids. They're not characterized by big bolids. They are smaller, faster meteors, as I understand.
Because the orbit is retrograde.
Okay. And the meteors are from,
Halley's Comet.
Halley's Comet. We get 2 meteors from Halley's Comet. There's one later in the year too, but this is the bigger one.
Huh.
We're passing through the orbit of Halley's Comet.
Well, actually, it's bigger. The October one, the Orionids, is bigger for us because it's more northern. This is
Oh,
a
okay.
southern hemisphere event.
Good point.
They can expect 50 meteors per hour from this. We can expect like 15.
But because of the word Aquarian, does that mean it's connected to Aquarius?
Well, there's
This
the
is
radiant point. Yes, right there.
This is the constellation of Aquarius,
Got
which
it.
goes, and that's its border there. It's a big constellation. And this is the rough radiant for where that is.
Mm-hmm.
Got a trivia question for Ronnie.
Okay, shoot,
What time in the morning is this right now?
4:30.
5. Okay, 5 o'clock.
Okay,
In 1 month, what
Right
time
there
will
on-
Fomalhaut rise? Don't tell him, Chuck.
Vogelhout,
Fomalhaut.
that strange German sounding star.
It's not German.
Oh, it's not German? Oh, boy, it sure sounds it.
It's
Arabic.
Arabic for mouth
It's
of the
Arabic. It's really screwed up Arabic.
Yeah, but it
Yeah.
sounds like French.
So the
Yeah.
question is, what time will Fomalhaut rise next month?
Okay, is it going to be later? I got to decide later. than
Nope.
5.
Nope.
Nope.
Earlier.
Yep.
It's 4 minutes earlier a day.
Well, then all the stars around it would rise earlier too. Then
The answer is 3 in the morning.
got it. 3 in the morning. Wow. And you vampires are up at that time with your scope. Right?
Oh, out looking, yeah.
Okay, gotcha.
But there was a neat exercise when I first was teaching the lab set for City College out at the museum, that I'd have the students take a little pea shooter or like a straw and write down the time that they saw a star rise. Okay. Then they also recorded for the next night when that star rose. And if they were really good, it was 4 minutes. It was a really neat exercise. It's actually one that Fred Marshak invented. I liked it.
So it's for each month, it's about 2 hours.
About 2 hours, yeah. 4 minutes, 4 minutes times 30, Tim.
But
1 year is 24 hours.
20 minutes is 2 hours. It's just rough.
I was just going to ask.
It's actually, Tim, it's actually 3 minutes and 56 seconds, if you would be on it.
Yeah, Tim, the 24 hours in a year, right? So 12 months, 24 hours, 2 hours a month.
Mhm.
2 hours a month.
Another way of thinking about it, Tim, is we go around the sun, okay, in a whole year about 360 days, right? 360 degrees. Okay, we move things around from our perspective 1 degree a day, right? Well,
Okay.
1 degree is about 4 minutes. Okay, so things will rise 4 minutes earlier each night.
Each night.
Yeah,
Okay.
each night.
Because
So
I was going to ask. I was
2
going to
hours
ask
a month,
earlier.
Tim, is just a good rule of thumb. 2 hours a month.
Earlier, I was going to ask. I think later this summer we're going to see Saturn in the evening sky.
Yep.
Oh yeah. Mm-hmm.
And I was actually going to ask how we do that math, and this is actually going to help me a lot.
And
Yeah,
Saturn moves so slowly that it applies really well to it. But something like
That's right.
Jupiter will move one constellation a year.
Right. And Ron was noticing that, or somebody was this morning, how Jupiter was actually moving out of Gemini towards Cancer. But it was really neat to watch Jupiter go rolling into Gemini for a while on retrograde, and now it's going prograde. So it's coming right out.
I gotta talk about this later. We're gonna go on, but I'm gonna ask.
Yeah, I don't want to, Jerry, this is your thing.
Yeah.
It is.
Unless you want me to keep
I
talking
was just
about
going to point out that over here is the Great Square of Pegasus.
Yeah.
It's my orientation constellation. I found the skies in Australia and New Zealand to be very confusing. Everything's upside
Yeah.
down, and
Yeah.
my brain doesn't work that way. But the Great Square of Pegasus is still the Great Square of Pegasus. It upside down square is still a square.
Yeah.
And we have two ladies up the street who travel a lot, and they were just in New Zealand, and they sent a message back that they found the upside down sky, very confusing. I told them to look for the Great Square.
Yeah.
Somewhere there's a horse with wings in there, so on that.
Jerry, would Shiat and Alpharats be on the lower corner of the square, looking from the southern?
Would what?
Would Shiat and Alpharats in the Great Square, would those be on the bottom?
Yes, it'd be just yes. This would be on the bottom. This would be on the top, and these two would be halfway.
Yeah. The horse comes up upside down.
Yeah.
Oh,
okay. His nose is Enif, Tim. See Enif up there?
Yeah.
Okay. Now I know this is a lot of advance notice, but it turns out that there's a program that's available to amateurs and everybody on the internet called Project Pluto. And it's open software for everybody, but you can track all sorts of odd objects, rocket boosters and debris. And it turns out on August 5th of this year, they are projecting that a booster, a second stage from a SpaceX launch last year in 2025, is going to hit the moon right up here on this side. And this is the view from Earth at that time. This is not a photograph of the moon. This is a map. And it was a Falcon 9 launch, and it was a Firefly's Blue Ghost Mission 1, which was named the Ghost Rider in the Sky. Launched in January 15, 2025. It performed the first fully successful commercial lunar landing on March 2 at the moon's Mare Crisium. And apparently it's stuck in an Earth-Moon orbit there. And so it's finally going to hit. The object is labeled 2025-010D, and it lobbed 2 spacecraft into space and is now headed for a run-in of the moon. The other object that it landed there was Japan's Hakuto R M2 lunar lander called Resilience. However, that probe was lost radio communication about 90 seconds before touchdown. And so it plowed into the lunar landscape and left a crater of its own, which I do not have a picture of, but it's around the backside due to a rangefinder malfunction. So anyway, this is right on the edge, but still on our side. So it's possible that if it creates a flash or a plume, it might be visible at that time. Did someone want to say something?
Well, what you just said, I guess it's going to be a large area. They can't pinpoint exactly where on the moon's surface or exactly what time of day on the 5th.
No, they got it pretty well computed. This is
that
the
little
crater.
blue dot.
This is straight down, looking at the Einstein crater. And right there at those crosshairs, that's where it's going to hit, on the inner wall of Einstein.
Good Lord.
So this is other craters that are hard to see over there, but we can see Russell, Struve, Hedden, and Vasco da Gama. I don't ever remember seeing Vasco da Gama. So these are hard craters to see, but the moon does have what's called libration.
Vibration, yeah.
So is that an Einstein cross?
Yeah. Good one. Okay, one for Tom. So anyway, the moon does twist, and it looks like this. If you photograph it as it goes through the month, it does this. So it exposes a little more than just the front 50%. You can actually see about 55 or 60% of the moon's surface, very obliquely, but you can see it. So there's a chance that you might be able to witness the impact.
Yeah, I don't think they think it's going to be very bright, but
no.
And they have the time of that impact?
I don't, but you can look it up on
okay.
The date is the 5th of August.
That's on Project Pluto, I guess.
Yes.
You can bet it'll be in a bunch of publications as we approach the date.
Yes, so you'll hear about more of it about that. Yes.
See, Project Pluto sounds kind of goofy.
By any chance, Jerry, do you have pictures of the Chang'e 5 T1 China that did crash?
I do not.
Okay.
Tom.
Actually, that's what this is.
That's what we're looking at?
That's a Chinese lander crash. Yeah, 5T1.
Not the one we just talked about, but this is a different lander crash, right? This image shows a pair of craters made in 2022 when the upper stage of China's Chang'e 5 T1 mission hit the moon. It was supposed to land, but it hit the moon, I think.
Well, this is the booster.
Oh, that's okay. Does it say that? Upper stage, you're right. This is the booster. One of the craters is about 16 meters across and the other one is 18 meters across. So these are not big craters, but you can tell they look a little sharper than the real fuzzy rounded ones here.
Oh.
So
the booster crashed, but the lander landed?
No, this is from the the lander landed, but this one was the second stage booster.
Huh. Wow.
And I think Chang'e 5 is the one that landed on the far side.
Yeah.
I'm sure China must have got a moving picture of this, at least.
How?
China did not supply the mass of the object, but NASA is estimating that it's about the similar mass to the event that's going to happen this coming August. So you can expect a crater of this proportional, roughly this size.
Hmm.
It'll be coming in at an angle of 34 degrees from the vertical, straight enough down that you won't expect the crater to be very elongated. And so the reactive plume should go up in the air.
This is not the other side of the moon, is it? Because that's where they were supposed to be concentrating their landings.
The booster doesn't necessarily hit in the same place that the lander goes down.
Yeah.
So everything they're doing is on the opposite side that we
No,
don't
not
see?
everything they're doing, but one of their missions was.
Yeah, the
Oh,
one
I
they
see.
grew tomatoes in a sealed container inside the rover that they landed.
So we have a booster that pushes like Artemis 3 out there, but where did it end up going? Is it orbiting the moon?
Probably.
And it's not going to crash, I guess.
This picture was taken by our lunar reconnaissance orbiter.
A double whammy. I wonder why it gave us two craters.
2 pieces.
Oh, 2 parts of it that
Yeah.
separated. Oh,
Okay, moving on.
yes. This is not the moon.
This is about starbirth regions in M33. The European Southern Observatory, ESO's very large telescope in Chile's Atacama Desert, photographed a cloud in M33. This is an atom block picture of M33, and this is either this cloud or this one. I think it's this one that they did the close-up photograph with the 4 or 5 telescope interference array. And this is the
Whoa.
this is the picture that they took very close up. It's of the gas. This is shown up here in hydrogen alpha. It's red. This is probably a closer color. This is based on chemical elements. It's using scientific filters. A close-up of the nearby, okay, M31. The image in blue represents oxygen. It's mixed in here and a lot up here and here. The green represents hydrogen. And red denotes the presence of sulfur. So those were 3 specific filters used. The ones here used by Atom Block are red, blue, and green, so they do not correspond to the colors seen here, different colors. So it's a very detailed picture of the
Triangulum?
what's that?
Is this the Triangulum galaxy?
Yes.
Yeah,
Mhm.
this is this.
And that's one of the many galaxies that orbits us.
This
Our
is
galaxy.
No,
Mhm.
It doesn't orbit
it's
us
part of the
or
local
Andromeda?
group.
Local
It's part of the
group.
local group.
Oh, just
It's
part
like
of it.
Andromeda. It's about the same distance away. It's a slightly bigger galaxy than ours. And I'm sure you've heard that Andromeda and us are probably going to in some way interact. And there's a possibility, a lower possibility, that Triangulum Galaxy, this one, may also be involved in a 3-way collision with us at about the same time. So about 5 billion years from now, we'll have very, very close-up views of this.
Well,
Great.
is there something triangular about it that gave it its name?
It's in the constellation Triangulum.
Well, is there something about that constellation that's triangular?
Yes,
What?
It's a triangle.
it's
Is
called
this
the
a-
Triangle.
So it's it's not your big Pegasus square, it's a big damn triangle, 3
Yep.
dots, not 4. All right. Got it. That's good.
There's our geometry, Ronnie.
Yeah.
This
Yeah.
is the VTL, the Very Large Telescope. Started work in 1998. It's run by the European Southern Observatory. It's
Northern
in Cerro
Chile?
Coronel in the Atacama Desert of northern Chile. They are listed as, and they're called Antu, Cuyen, Melipol, and Yipan, which are words for astronomical objects in the Mapuche language, which is local to that region. These are all hooked together. They're each 8 meter let's see, 4 movable telescopes. Doesn't say the size.
Oh, the small ones are the movable ones, the little white domes you see.
Yes, and those ones are 1.8 meter.
Wow.
And you can see they have the railroad track like assembly,
That's
like the
pretty
VLA, so they can have different configurations.
Yes.
The mirrors are 1.8 meters, just almost 6 feet across. Is that what
On those little ones, yeah.
Yeah.
oh, but they're connected. They're like a vast array of radio telescopes.
Yes, it's an
They all look at-
interferometer.
I'll be damned.
Now, each one of these telescopes has approximately 0.05 arc seconds resolution.
Wow.
The big ones, yeah.
But ganged together, they have 0.002 arc seconds.
Oh, Jesus.
So a gain of 20 over the single one. And it's that telescope combined together that gave the picture of the gas in M33.
Uh,
Hmm.
I never understood how they work that. Never understood it, but it's really neat.
well, I
You
suppose each
know,
one.
we have a telescope called there's one that's got 7, 1, 2, 3, 4, 5, 6.
The Char array down at Mount Wilson.
No, I'm thinking of bigger things than that. They've got 3 or 4 of the mirrors made. They're 8-meter diameter mirrors. They got one in the center and the rest go around it, and they all come to a single focus because each mirror is made and their figure is tilted to bring the light to a single focus. And so that's a case where these telescopes can be ganged together. They're optically ganged together. The mirrors all tilt to put their image in an overlapping place on a sensor. But you don't have to do it that way. You can have each mirror focus on its own sensor, and then you combine the signals electronically. And
Oh,
that's what they do
interesting.
here.
Are we talking about down in Chile or here in America?
Well,
Oh, yeah.
the
Down
other
in-
one that Jerry was talking about is a multi-mirror telescope, but that's
And I forget the name of it. I think it's called the Giant Magellan or something like that.
yeah.
Well, they're all down there in the Atacama, aren't they? The Vera Rubin, which has 1 trillion pixels behind its camera. Is that possible?
Yeah.
Trillion pixels. Good Lord. But the Magellan, I've heard of it. I've seen the layout. We've covered it. You know, the size and structure of those mirrors, just amazing.
There's one that's a giant binocular.
Yeah, that's in Arizona.
And LCO's worldwide network, they're all what, 1 meter, 2 meter?
They're mostly 1 meter, and there's a couple of 16-inch meads with each 1 meter
Okay.
that have been
And-
heavily modified.
But like all those Chilean scopes are in the north around that desert where I guess the viewing is incredible and it's dry as hell, and they each pick up different mountaintop, I guess, don't they? They're
And cold as hell.
cold as hell.
Okay.
Interesting. We have the night sky, ladies and gentlemen, on the screen again.
Okay. So now we're going to take another look. My attention gets captured by pretty pictures. So the other one that got me was the Sombrero Nebula. And that is located,
Corvus.
yeah, M104 in Corvus, the Sombrero Galaxy. This is a picture of it at 9 in the evening. It's more southerly. And I think it's heading, this is east. So it's heading this way. No, that can't be right.
Yeah.
Yeah.
Okay, so it's heading this way. And This is about as high as it's going to get. It's a more southerly object for us, but I've taken pictures of it when it's up in this region somewhere. It's easy to do if the sky is clear. And this is from the Sky 6, showing the location of it. This is a zoomed in picture of the Sky 6 with it. This is the M104 Sombrero Galaxy here. You can see these three little star asterism here and something over here called the Stargate, which I've never heard of before. And if you go to a picture, a wide angle picture of the sombrero.
Really blown out.
Okay.
Yeah. That's a little arrow stars that get you there.
Yeah.
Yeah, the arrows are what I always use.
Mm-hmm.
Okay.
You know you're in the neighborhood.
Oh yeah, it points right to it.
Would it be fair to say, gentlemen, that edge-on views of galaxies like the Sombrero are rare? Most of them we see full-blown,
No, it's
or
pretty random.
are they about equal?
It's pretty random.
Is it? But
Oops, that's the same thing.
it's one of the most common or one of the most famous of the edge-on because it looks like a hat, like a
Yeah.
Mexican hat.
Well, but a hat edge on.
Yeah, exactly.
A sombrero.
Wonder if there's a galaxy out there called a bonnet.
Well, you can apply that probably to Thor's helmet.
It makes you wonder, does the bar affect the bulge? Or is it only part of the, oh, never mind.
Oh, there we
There
go.
we go.
That's a nice shot.
Okay. Now these are those three stars that we saw off to the side. This is, of course, the sombrero. This haze around here is actually star clouds from the sombrero. And the this sombrero has over 200 times, let's see, over 2,000 globular clusters, nearly 10 times more than the Milky Way does. So this circular thing around here, you know, globular clusters orbit a galaxy like ours, not in the plane of the disk, they orbit around in the sphere of the disk. So the globular clusters form sort of an Oort cloud around the galaxies. They do that with this, but it's 2,000 times more globular clusters. Very old globular clusters or clusters. This is located 28 million light years from Earth and has a magnitude in the sky of +8. So you ain't going to see it, no matter how dark the sky is with your naked eye.
So you're saying, Jerry, that foggy sphere we're looking at around the galaxy, which is flat, is full of stars?
Yeah,
Yeah.
that is unresolved stars.
Wow. And they're all star clusters. They're not just,
No,
No,
there are star clusters too.
oh, I see. Oh, concentrations of stars. Okay.
Yeah.
Wow. And we have
So
that
that's a
going
very
for,
dramatic picture.
but the same thing happens with the Milky Way?
The Milky Way has about 200 globular clusters. This one has about 2,000 globular clusters.
But our globular clusters are within the Milky Way, aren't they? Or are they out
No,
beyond?
look, all globular clusters around whatever galaxy they're around, they all have this spherical region that they occupy. They do not conform to the plane of the galaxies. Many of them pass through the plane of the galaxy.
Well, you know, an elliptical galaxy would be nothing but that. No,
Yep.
no
Yeah.
disk at all, right?
Right.
This might be a hybrid between the two.
Jerry, with globulars, they can pass through the plane of the galaxy as well,
Yes.
correct?
Yes.
Yes.
Wow. So some of these star clusters we look at are technically outside of the disk, the
Yes.
round
Oh,
flat.
yeah,
Yeah.
absolutely.
I didn't know that. Thought everything was contained in the arms.
Nope.
Okay, now we had an excellent speaker at our club last Friday.
Abigail Freeman, JPL.
Yeah, Abigail Freeman from JPL. Where did I just hear that? Anyway, she showed us from the Curiosity rover. She covered the lifespan of Curiosity rover about what is it, about 10 years, 5 years?
13. We're going on 14 this year.
Okay. And different types of things, the terrain they've gone. This thing is climbing Mount Sharp up in Gale Crater. And they've come up to this region where they call it the Boxworks. This is it from orbit. And you see these ribs here, sort of like hard spots as things get eroded away and stuff.
Spider
And
webs.
what's that?
It's kind of like a spider web, I think.
Yeah. And this is from orbit, and this is down on the ground with the rover looking at them. And then farther up Mount Sharp. These are on Earth, these occur, and they are caused by fissures in underlying rock layers where some kind of material oozes up through the fissures, and it's a harder material than what's in here. So, and these were pools that dried out this way. This is clay that solidified and became harder, and it's harder to erode. So as the winds erode thing, they take away the softer stuff first, and they leave behind these ribs. This is called the Boxworks on Mars. Her talk was excellent, one of the best I've seen.
Yeah, she's very
Well,
dynamic.
the thing that stupefies me, gentlemen, is that water, to be a liquid, has to exist between 32 degrees and 212 degrees Fahrenheit, which
Depends
means
on the
Mars,
pressure. Depends on the atmospheric pressure too.
the pressure has. So could Mars have sustained liquid water at different temperatures than on Earth? Liquid, I'm talking about.
Yeah, depending on the atmospheric pressure.
If it's on Mars now, it's got to be ice. There's no way we could ever see anything bubble up from beneath or whatever.
Nah, not necessarily true. There's salt mixed in, and that changes the equation a little.
Oh,
Interesting.
it's like an antifreeze.
Well, the thing I liked about Abigail was that she was one of the few speakers we've had that looked exactly like her picture. I got to tell you right now, gentlemen.
I thought she got lost until she jumped up on the stage.
Oh,
So
she was awesome. She was a
I
sweetheart.
couldn't jump up on the stage like that.
I got her by writing her a letter on a piece of
Okay, good
scratchy
job.
note. Yeah. Well, we may have her back in a year or two when that sucker gets to the top of the Mons. Gentlemen, are we done? I guess we'll have to wait another week. In the meantime, I guess we're going to gather on Saturday night at dark, which is 8 o'clock at the museum with our telescopes.
Official start time is 8:30.
Okay. Tell your friends about us and join us in Star Party Saturday. Sunday afternoon, we'll meet online for our planning meeting, and we say something called Hasta to
Hasta
say goodbye.
Nebula.
Hasta Nebula.
Yeah.